This is Mrs. Palmer-Quay with the fourth video for Module 1. In this video, I'm going to talk about density. So what is density? Well, density is a ratio, it's a fraction that compares the mass of an object to its volume. Technically speaking, mass is how much substance is in an object, and it doesn't change if you take an object into outer space, whereas the weight of something can be different in different places. But since we're all going to be working within the same gravitational field here for our chemistry experiments, when we're talking about mass, we're usually determining that by weighing it on our balances. The ratio of a mass of an object to its volume then represents its density. It's expressed in this formula where the Greek letter rho equals m divided by v. If you think about two objects with about the same volume but very different masses, you get a good sense of density. So we have a bowling ball here and a volleyball, and you can see they occupy about the same amount of space. They have the same volumes, so their volumes are the same. But the mass of this bowling ball is much greater than the mass of the volleyball. So if we put the mass over the volume, we're going to have a much bigger number when it comes to the density of our bowling ball than the mass over the volume of our volleyball. Density is known as an intensive property. It's something that doesn't change depending on the size of the sample. So that if you have a glass of water, a small size sample of water, or a swimming pool full of water, the density of water is exactly the same. We'll be using the density of water a lot this year. It's a very convenient number. In fact, it was just picked when scientists had to set some arbitrary rules. Water was decided to have a density of 1 gram per milliliter. That becomes handy in doing experiments because if we need to measure out 100 grams of water, well, we can just measure out 100 milliliters and know that we have 100 grams. Density, though, can change. With most substances, it changes with temperature because most substances expand when they are heated. And so we have all seen these little zipper-like attachments on bridges and roadways, and they are set up so that as the roadway is heated, as the sun beats down on the asphalt and that asphalt expands, your road will not buckle, that the zigzags, they'll just slide towards each other, and you have a little bit of expansion space there. So you have the same mass. The road is not changing in its mass. It's not getting any more substance or stuff in it, but it's taking up more space, so it has greater volume. And actually, overall, then your road has a lower density when it's really hot. The international units, or the SI unit for density, is kilograms per cubic meter, but that is quite a large amount. And so in lab, we tend to talk about grams per milliliter, or remember, a milliliter is the same thing as a cubic centimeter, so grams per cubic centimeters. So we have some examples down here that in 1 cubic centimeter foam you have 0.3 grams. Obviously, there's a very low density of that product. A diamond in 1 cubic centimeter, you have 3.5 grams. And then, of course, iron, a very dense product, in 1 cubic centimeter, you have 7.8 grams. So since the value would be grams over cubic centimeters, then we could say the density of foam is 0.03 grams per cubic centimeter. For diamonds, it's 3.5 grams per cubic centimeter, and for iron, it's 7.8 grams per cubic centimeter. If we were dealing with liquids, we would probably be using milliliters instead of cubic centimeters as the volume measurement. Gases tend to be measured as grams per liter since they spread out and take up a little bit more space. We can calculate not only to find the density of something based on a mass and volume, but we also can use the density to find an unknown mass or volume by rearranging the formula. So if our formula for density, or our textbook uses the Greek letter rho, if density is mass divided by volume, and again the units here don't matter, as long as you have a mass unit and a volume unit there, that's fine. You can rearrange the formula to have mass equaling density times the volume, or volume equaling the mass divided by the density. So just to model doing these sorts of calculations, say you have a question that asks what is the volume of 50 grams of aluminum if the density is known to be 2.70 grams per milliliter. This milliliter again could also be cubic centimeters. So notice also we have 3 significant figures in both of our measurements, and so our answer is going to have to be in 3 significant figures. So to set this up, we've got our base formula, rho or density equals mass divided by volume. And there are 2 ways to do this. You can just start with that particular formula and plug things in. So I get 2.70 grams over milliliters equals 50 grams over x, and that is one fraction, 2.7 grams per milliliter, standing up against another fraction. And you might remember from math class that when you have 2 fractions separated by an equal sign, you can use cross multiplication to solve. So I could multiply the 50 times what is really 1 milliliter over here, so we get 50 grams per milliliter on one side of your, or 50 grams milliliters times milliliters. So we got 2 units times each other here. On one side of your equal sign, and then you've got 2.70 grams times x on the other. And then you just solve for x by dividing by 2.70 grams, and your grams will cancel out, and you're left with milliliters in your answer. So I'm really fond of cross multiplication. You multiply and then take the answer to the numerator side. You can also, though, rearrange the problem if that's more comfortable with you. So you can go from density equals mass divided by volume to taking volume equals mass divided by density. To get there, you're going to be, multiply both sides by volume. So we times volume. You cancel out these volumes. You divide by rho, and you end up with this as your formula. So again, you would plug in then that your volume, your x, is going to be 50 grams divided by 50.0 grams divided by 2.70 grams per milliliter, which is essentially what you've got right here as the end result of cross multiplication. So in either way, you're going to get the same answer. And that answer would be 18.5185, etc., etc. And so this would be in milliliters when you've canceled out the units. We want to make this answer to have the right number of significant figures, which we already figured out, which was 3. So we look at, here's our third one. Right next to that is a 1, so it's not going to change anything. So 18.5 milliliters would be the volume of 50 grams of aluminum. So either way, by cross multiplication or by rearranging the formula first, you can see we end up with the same mathematical division statement that we want to do at the end, and so we'll get the same answer. So that covers what I wanted to say about density and finishes up the videos for Module 1.